A circuit breaker is an electrical switching device that automatically interrupts the flow of current in a circuit to protect the electrical system from damage caused by overcurrents, short circuits, or electrical faults. It is an essential component of electrical distribution systems, providing both safety and convenience. Here are some key points about circuit breakers. 1. Function. The primary function of a circuit breaker is to protect electrical circuits and equipment from excessive current. When a fault occurs, such as an overload or short circuit, the circuit breaker detects the abnormal current flow and quickly interrupts it to prevent damage to the circuit or connected devices. 2. Types of circuit breakers. There are several types of circuit breakers, including thermal circuit breakers. These types of circuit breakers use a bimetallic strip or a thermal element that bends or deforms when exposed to excessive heat caused by an overload. This deformation triggers the tripping mechanism, opening the circuit. Magnetic circuit breakers. Magnetic circuit breakers operate based on the principle of electromagnetic induction. They have a solenoid coil that creates a magnetic field. When a short circuit occurs, the excessive current generates a strong magnetic field, which activates the tripping mechanism and opens the circuit. Hybrid circuit breakers. Hybrid circuit breakers combine both thermal and magnetic elements to provide protection against a wide range of overcurrent conditions. Electronic circuit breakers. Electronic circuit breakers use solid-state components, such as transistors and sensors, to detect and interrupt abnormal currents. They offer precise and adjustable protection settings and are commonly used in electronic systems. 3. Tripping mechanism. When a circuit breaker detects an overcurrent or fault, it activates a tripping mechanism to open the contacts and interrupt the current flow. The tripping mechanism can be mechanical, electromechanical, or electronic, depending on the type of circuit breaker. 4. Ratings. Circuit breakers are rated based on their maximum current carrying capacity, known as the current rating. This rating determines the amount of current the circuit breaker can handle without tripping. Circuit breakers also have voltage ratings, indicating the maximum voltage they can safely interrupt. 5. Circuit breaker panels. Circuit breakers are commonly installed in distribution panels or breaker boxes. These panels contain multiple circuit breakers that protect individual circuits or groups of circuits in a building or electrical system. The panels provide a convenient way to control and protect the various electrical circuits. 6. Testing and maintenance. Circuit breakers should be periodically tested and maintained to ensure their proper functioning. Regular inspections, cleaning, and testing of the tripping mechanism are important to identify any defects or malfunctions. 7. Resetting. After a circuit breaker trips, it needs to be manually or automatically reset to restore power to the circuit. Some circuit breakers have a simple manual reset switch, while others may require troubleshooting and fixing the underlying issue before resetting. Circuit breakers play a crucial role in safeguarding electrical systems and preventing hazards such as fires, electrical shocks, and equipment damage. They are an integral part of residential, commercial, and industrial electrical installations.